this again. Okay, hello everybody, and welcome back to another video. Today we're going to be doing the math homework, which is this worksheet and the Untitled document. Also, today there's no school, which is cool. Okay.
We don't want no heroes in a generation so sick of labels. We don't want no heroes. We don't want no heroes.
So first we have to watch this video, so let's watch it.
The relationships you have seen so far are called functions. A function, like the one shown in this graph, is a relationship in which each value of the independent quantity, or each x value, is mapped to just one value of the dependent quantity, or y value. You can write every function in this form. F of x equals y. F is the name of the function. The x in parentheses is the input, also called the argument of the function, and y is the output. The kind of function shown graphed here is a linear function. It is a straight line. You can write the equation for a linear function as f of x equals mx plus b. Linear functions can be increasing, decreasing, or constant. They do not have maximum or minimum points. Here is a graph of a quadratic function. The graph of a quadratic function is curved in a U shape. The equation for a quadratic function is f of x equals ax squared plus bx plus c. A quadratic function can increase to its maximum and then decrease, or it can decrease to its minimum and then increase. And here are three more function types: exponential, cubic, and a linear absolute value function, along with their equations. What characteristics do you notice about these kinds of functions?
Okay. We have our functions. We have what we need. So a function maps each input into Okay, so basically let's start with number one. Okay, so a function maps an input to one and only one input, because you know that if like the input is 4, then the output can be 3. If the output is also 0, then that's not a function. But one output can have multiple inputs. For example, 4 can have 3 as an input, and 5 can have 3 as an input. So linear function has no maximum or minimum. You remember them saying that in the video. And is the name of the function represented by the equation L. The equation A represents a linear function, so I think we have to figure out which one is in mx plus b form. Mx plus I'm going with that one because, like, did I even get it right? Oh yeah, I did get it right. And then quadratic function, the quadratic function is ax squared plus bx plus c. So that's like ax squared plus 4x minus 5 is abc. A is 1. And then the exponential function is right over here, fx equals ab squared. So the exponential function obviously isn't going to be that because that's absolute value. It's going to be that one because oh yeah, the x is going to be the exponent, so x is going to be that. the graphs of the functions are straight lines, right? And then the function fx is so fx is going to be linear because it's straight. Oh wait, they're talking about, okay, well then it's going to be decreasing. Gx is going to be increasing, and hx is going to be constant. The function fx has a maximum, no maximum or minimum. The function gx has no maximum or minimum. The function ax has no maximum or minimum. In the equation of a linear function, the independent variable is raised to a power of 0 because there can't, no wait, not 0, I mean 1. Because there can't be any exponents in linear functions. Okay, the graphs of the functions are curved lines. I think they're talking about these two. So BT, wait, which one's BT? BT, I'm guessing is this one. So BT is a increasing function, and that's decreasing. And then in each equation, because x is the independent variable. And BT has no maximum or minimum. PX has no maximum or minimum either. So BT appears to have a horizontal asymptote. I don't know what that means. Maybe they'll say it here somewhere. An exponential function may have a horizontal asymptote. An asymptote is a line which a function approaches but never reaches. Is a line which a function... So an asymptote is like what it's going towards, but it'll never reach. So BT is never going to reach 0, and BX is never going to reach 0 either. Why can't B equals 1 in an exponential form of the... Why can't B equals 1? Why can't B equals 1 in an exponential form function of the form B that? I think because it wouldn't be a function, maybe? No, it would still be a function, but it would not be an exponential function. Oh yeah, it would be constant. How did I not see that? Quadratic functions. Okay, the function PW, which I'm guessing is this, has an absolute maximum, because that's the maximum. And the graph increases to the point 75 to 50. Is that it? What? What do they mean by putting... Wait, what? I'm so confused right now. The coordinates are at the point... The absolute maximum, yeah, that. That's... I did that. Are you telling me that I have to put the parentheses around that? 75, 11, 250. There's your parentheses. Okay. Okay, now FW has a absolute minimum. And its point is negative no wait, parentheses, negative 4.25, comma, negative 72, enter. The graph of PW is symmetric about the line X. What do they even want us to type? Oh, X equals 75. And then over here, it's going to be Y equals, they showed 0. They literally have a line over there. No, wait. But there's a line over there. Maybe it's like, oh wait, it's negative 4.25. Okay, the graph on either side of the axis of symmetry is a what line? Curve, because both of these lines are curved. And the equation for a quadratic function, the greatest exponent is x? Question mark? Question mark? Okay, is it y? No. Ooh, I think I know what they're talking about now. Is 2. Oh, they meant exponent. Okay, I read that wrong. It's 2. That makes more sense. The function f(x) has a absolute minimum, absolute maximum, 260, 0. It literally says 260, 0. Oh yeah, parentheses. (20, 40). The function f(x) is symmetric about the x line is 260, I think. And then the x line over there is going to be 20. The graph on either side of the axis of symmetry it's a straight. And then in the equation for linear absolute value function, the independent variable is always in a pair of absolute value symbol. Okay, so now we have to sort these. And linear exponential. Okay, so now the linears are going to be in mx plus b form. Okay, and we know the absolute value functions are going to have absolute values in them, so we can take all these in there. Any other absolute values? No. But mx plus b. I wonder if that... Because it's like mx plus b. Okay, that has an exponent, so that's exponential. That is also exponential. Oh, wait, I forgot. It's squared. In exponential, it has to be x. Okay, that's going to be linear. That's going to be exponential. That's going to be quadratic. That's going to be quadratic. And that's going to be linear. Okay. I think that's it. Your effort defines description. Loading? Okay, continue. No, wait. Is this? Let me go back to the unit overview. Okay, so I finished those two. Wait a sec. Okay, yeah, I did. So all we have to do, I think, is what? Just do the. We just have to do the workspace function families and then page 61 and 62. Okay. So now that we're done with that, we move on over here to this Google Doc so that we can do the others. What is that? Okay, so for the assignment, for write, I'm going to do number 1 and 2 for you guys. For practice, I'm going to do number 1. I don't think we have to do number 2, so number 1 and 3. For stretch, we don't have to do stretch, I'm pretty sure. And then for review, I'll do A. So just so that you know which ones. So the term best completes each statement. So blank is a way to represent equations algebraically that makes it more efficient to recognize the independent and dependent variables. Okay, so for this one, so is a way to represent equations algebraically that makes it more efficient to recognize the independent and dependent variable. Well, that's going to be function notation. And number 2, when both the independent variables of a function increase, that just gives it away, increasing function. The decreasing function, I'll give you a hint, it also has the word decreasing in its thing. And then remember, a function is a relation that assigns each element of the domain to exactly one element of the range. The different function families include linear functions, exponential, quadratic, linear absolute, and linear piecewise. Piecewise, yeah. Okay, so then for the practice, we have to identify the function family, whether it's increasing, decreasing, or a combination, and has an absolute value of absolute maximum or minimum, and whether it's a smooth curve or a straight line. So for this, we're going to need Desmos. So, a fitness company is selling DVDs for one of its new cardio routines. Each DVD will sell for $15. Due to fixed and variable cost, the profit the company will see after selling the X DVDs can be represented in the function. Blah, 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 blah. So, we have to graph that. So, 11.5. It's basically Y P X equals 11.5 X minus 0.1 X to the power of 2 squared minus 150. So there's a graph. Oh, it's a good thing I zoomed out. Okay, so that's a graph, and I need to check something. Oh. Okay. I just had to check that the px wasn't making any difference. So over here, as you can see, the identify the function family, that's going to be a quadratic function. And the reason why is because it's in, so quadratic functions are in like ax squared. So our ax squared is going to be up there. bx is over here, and c is going to be 150. That's the content. So it's going to be quadratic is this function family. Okay, so next, Increasing, decreasing, or a combination. Well, it's a combination. So absolute maximum is up there, up here. And then a smooth curve or a straight line, that's going to be a smooth curve. We don't have to do number 2. So we move on to number 3. Now number 3, the equation is going to be AX equals 500 times 1.03 to the power of x. So that's going to be a weird graph, actually. So $500. Shari is going to put $500 into account with the People's Bank. The bank is offering a 3% interest rate compounded annually. The amount of money that Shari will have after X years can be represented in the function. That. Now, what function family is that? It's going to be exponential since the exponent is x. So and then increasing or decreasing. It's like it goes straight and then it increases. So increasing. And maximum or absolute minimum has an absolute maximum or an absolute minimum. Technically, it goes on forever, but I can like looks like it's trying to reach 0, but it's never going to. So like maybe 11 absolute minimum. 3 is confusing. I don't know if it has an absolute max or minimum. So for now, I'm going to put minimum, and in parentheses, neither, because I don't know for sure. Neither. And then smooth curve or straight line, that's going to be a curve. Alright, so you can do 4 and 5 by yourself. Stretch, we don't have to do. Now review, I'll do A and number 2. So identify the axis of symmetry each graph has and identify the amount of quadrants. So the axis of symmetry. So let's take a look at the first graph, which is... So for the axis of symmetry, identify the axis of symmetry. Well, if you take a look at number 1, it's like right over there. So like number 1 is like written like that, and the axis of symmetry is going to be like right over there or something. And then the amount of quadrants, it's going to be passing through all 4 quadrants. On second thought, you can do B by yourself, and you can do 2 and 3 by yourself. So thanks for watching. Make sure to subscribe and like the video. If you have any questions, or if you want me to do like, for example, for right, if you want me to do like 3, 4, 5, 6, then just tell me and I'll do it. If you want me to do like 5 and 6 for practice, tell me and I'll do them. And if you want me to do B and 2 and 3 for review, just tell me and I'll do all of those. So I hope you enjoyed, and I'll see you guys later.